Alrighty, so here we'll be going over how we get the Pi running and get the robot driving around. So for starters, I'll turn on the robot. That's pressing that button in so it's depressed over there. I've got a wireless keyboard or wired keyboard and mouse set up, connected up to the Raspberry Pi, and got the monitor plugged in with a micro HDMI cable. So you'll see here we have our Raspberry Pi OS stuff pop up. We're loading into it. And now that we're in, we'll use the terminal. That's this little symbol up here on the thing to access VS Code. So we'll type in code space dot, press enter, and that'll pop up VS Code for us. So we'll make that full screen here. Now, because I was just messing around in the PyBot repo, and because you downloaded an image that I was working on, you'll probably see this recent right here. So you can go ahead and click on that to pull it up, but in the case that you don't have that, I'll show you how to access it. So we'll go to Open Folder, click into EDUBot here, click PyBot repo, don't double click, single click, come down here and click Open. So now this will pop this open, and because we were just in a container, this will be down here and it'll prompt us to reopen in container. Again, you could click that, but in the case you miss it, you can then on your keyboard Control-Shift-P, pop open this nifty guy here, and then you can click either rebuild and reopen or just reopen. Up to you what you do. I'll show you rebuild and reopen. This will be the most drastic potential change. So now down here in the bottom, you'll see connecting to dev container, click to show logs. So you'll click on that and then you'll just see a bunch of code stuff scrolling along. And we got this, we're running our post create commands, and then we're good to go. So one thing that's worth noting, if you are having some issues with running colcon build, I'll show you in a second what that does. But if you're running into issues, go pop into your devcontainer.json, and at the end up here, you'll see these commands, this line here. Just go ahead and pop that down into a new line. I was running into some issues, and once I did that, it fixed it. So that'd be my recommendation if you run into issues. If you don't have issues, you don't need to worry about that. So now to pop open into a new terminal, I just press this plus over here, and then that brought me into this terminal. And now on the left here, we'll hop into the README. So you'll see here we got src, you'll click that, and then click on PyBot, and then down here at the bottom, you'll see readme.txt. Pop into there and follow the instructions. So for starters, we'll run this in our local terminal, and that lets us be able to graphically visualize the LiDAR data using RViz. And the trick I used there was with that highlighted, I then middle clicked, and that pastes it. So now popping into here, we'll need to build our workspace. So I'll highlight that, middle mouse click, press enter. Now we're building. So this is building our ROS2 workspace. It'll take a second for it to build the LiDAR package, and usually it fails on the first try. It's just how ROS2 is. It can be kind of temperamental. If it fails, then you'll just rerun it and it'll be all set to go. So while that's running, I can give you guys kind of a tour of the code that we have here. So to control the PyBot, we have our main launch file. This launch file calls the two nodes that we have for controlling the robot. So the first one is the encoder data. So this is a publisher that's reading the encoder data off the wheels and publishing it as a ROS topic. And our second one is motor control. This is a node that's subscribed to a teleop twist. So that's how in ROS control of a robot is typically done, is with a teleop. So that gives you a linear and rotational velocity, which the robot tries to meet. And you'll see here that we had that failure. So if you just press up on the keyboard, that puts that command that we just ran right into there, and then you can press enter. It'll rerun it, and lickety-split, it finished successfully. So now we can pop back into our README. I've got that way at the top up there. Pop into it. Now we'll want to source the local ROS workspace. So we'll need to do this in each new terminal tab that we open. So if we make a new tab using this right here, we can split the terminal. So now we got two right next to each other, and again, we'll need to run that in that terminal. And we're going to be running three things, so we'll make a third. And source. So to run that launch file, to start up the motor control and wheel encoders, we'll run that right here. So now that has the robot primed and ready to drive. Now to launch our visualization of the LiDAR, we'll run this one. RViz will pop up, and then you'll see we have LiDAR data. You can see me moving my arm. That's that line there. So we're getting live data. Now to control the robot, we'll run this teleop twist keyboard. Now, depending on how you wired your robot, at this point you're going to see whether you wired it correctly. Whether you wired it in such a way that it will drive straight or drive in circles. So that I don't have a runaway robot. It'll balance it. Maybe not. I'll drive quick. So you see here that we have, this is that teleop twist. So I should drive your robot forward, comma should drive it back, J rotate left, L rotate right. So I have set the robot up with this direction forward, so it's like the reverse of if this was a tractor. So you've got the two wheels on the front and you've got a dragged caster wheel in the back. So real quick, I'll just drive it forward. So there we go. You can see how I can drive the robot. And with it, now if we pop back over here, you'll see that the frame for the LiDAR has kind of changed because the robot is now in a different orientation. So see that? You guys that are working on the robot will be able to take all this data from the wheel encoders, from the LiDAR, and a camera if you add it also, and be able to do some really sweet stuff with being able to map, be able to get that map so it stays stationary when the robot's turning, using wheel encoder data and data from the LiDAR. Whole bunch of cool projects that you guys can use. And for that, you'll be interacting with these ROS topics. So some of you guys might be asking, well, what's a ROS topic? The best way to get started looking at ROS topics is pop into your new terminal, run source source install setup.bash. Now we can ROS2 topic list. This will give us a list of the current topics that are being published. So you'll see there we have the command val and the joint states. So the joint states are our encoder values, and our command val is the value that's commanded from the teleop twist and taken by the motor controllers. And then these additional topics are coming from the LiDAR data, as well as the RViz visualization. So now say we want to find something out about the topic. We can do ROS2 topic info, and then type in the topic. So let's look at joint states. And I just tab completed that. So I type JO, press tab, and that was allow me to tab complete. So we see that the type is a sensor message, it's a joint state, and there's one publisher. So now let's say that we want to see that data. We can pop over here and we can do echo rather than info, run it again, and now it's just publishing the data. So now as we rotate the wheel, you can see those values changing. So we have our frame left, right. So the top one is our left wheel encoder value and our bottom one is our right wheel encoder value. And then we have a velocity. So right now, actually, so you guys can see how we're doing that. That's in our encoder publisher. Pop into here and you can see that we have get our velocity with this math right here. So if you guys want to try to improve the quality of that encoder data, that'd be a fun project. Add some filtering so you don't have this bouncing around when it's stationary. There's some cool stuff you guys can do right there. Now for so this kind of gives you guys an idea, an introduction to how you can run it and how you can interact with it. Now, if you want to create your own node, I recommend popping into Google here and taking a look at the ROS2 Jazzy documentation. Let me make this full screen. So in the if you just Google ROS2 Jazzy, you'll find this documentation here and pop into the tutorials and take a look at writing a simple publisher and subscriber. This is what a lot of you'll be developing will consist of. So you'll subscribe to a topic. So for instance, you would subscribe to the wheel encoder data and the LiDAR data. You'll do some math, and then you'll publish a motor control value. So then that way you could have the robot drive to a certain position or avoid an obstacle or do something like that. It'll basically consist of a subscriber and publisher. And here on the ROS2 wiki has a lot of great documentation to get you guys started. Again, if you have any questions, let me know, and I'll try to get some information posted on that as well as some more tutorials. So that's all that I've got for you guys today. Have a good one.